Well, hello, and thanks for making it to video 2 of my Prophusion demonstrations. So if you watched the first video, just within the space of a couple of minutes, I showed how to pull in any PHP release of your choice and load that up within Apache and just look at the PHP info page in your web browser. And that might have given you a quick idea of maybe how you could do some manual testing of a web application in any PHP version very easily. But it wasn't really the use case that I had originally envisioned for Prophusion, which was for automated testing. And so I wanted to do a video that shows how you can do, a more advanced automated testing scenario as well. So this video will be a bit longer. I apologize in advance if it is too much so, but hopefully it is useful. So what I have set up here for demonstration purposes is a very small PHP application. It has a pretty standard structure using Composer. And really all I'm trying to do with this is make a really small piece of code that we can test using phpunit and then load that phpunit code into Prophusion and run it on a bunch of different PHP versions. So this is the extent of the code that I'm planning to test. And then here are the tests themselves. In fact, there's only one, and it just makes sure that 1 plus 2 equals 3, etc. I'll show you the composer.json very quickly. There's a few interesting things in here. If you're not familiar with Composer, plenty of other videos that cover that other people have created, as well as documentation on getcomposer.org, etc. Definitely check it out. But the things that I do want to call out specifically in this one is so I set the phpunit version in the require dev section to be pretty old. And that's so that I can also tell it that, hey, I want all of the dependencies that you pull in for any package to support PHP 5.4. Otherwise, what Composer will do is it'll look at the PHP version running on the host machine where you run Composer install, and it'll just assume that that PHP version is fine for dependencies that are downloaded. That doesn't work so well if you're going to use it with Prophusion. You end up with a bunch of stuff in your vendor folder that are potentially newer than the oldest PHP version you're going to run within Prophusion, and things blow up. So the platform attribute can potentially be pretty key. You would just put the lowest PHP version that you intend to support with your project in here. All right, so I have already done all of this, and I have already, run Composer install, etc. And so what we have is let me clear this all out. What we have is a working project that I can run phpunit just within my host environment as you would always run a phpunit project. I'll go ahead and do that really quick just so you see that it does in fact work. We'll run vendor bin phpunit, and we'll have that phpunit run all of the tests within the tests directory. And surprise, it runs very quickly and does in fact pass that one test and 3 assertions. Great. So what if we want to test this with Prophusion in other PHP versions? So since Prophusion is a Docker-based thing, what you're actually going to do is do a Docker run in order to use it. Now we got to tell Docker a number of different things, and bear with me while I go over this somewhat long command. I want to show you all of this because I think seeing all of the pieces involved is helpful. Once we have that, I'm going to use this tool called Docker Compose that you may have heard of as well, that basically lets you pre-program in all of these presets so that you don't have to type out a really long command every time you want to run your tests. But for now, let's do it the simple way first. So what all should we tell it? We should tell it what PHP version to use. That seems like a good place to start. And the Prophusion project will read that out of an environment variable if you define one. So let's make this environment variable called PHP version, and this is all you have to do with Prophusion to have a PHP version of your choice. Let's do 7.0.0 for now. We also need to give Docker the path to to our application, basically. We're going to do that with the -v switch that creates a volume within our container. And we're going to base that on the code, within our host machine that we just ran, and that lives at /home/mic/profusion demo on my machine. If you had your code checked out somewhere else, you just put that path. And within the container now, we're going to have that show up in /app. It uses this semicolon, or sorry, this colon notation to designate the end of your path on your host machine and the beginning of the path that you want it to appear as in the container. Then we just put the image that the container should run, and this is the image off of Docker Hub. For our case, just the Prophusion base image is sufficient. If I can spell. Okay. And let me just say quick, if you were doing testing that required like Memcached or MySQL or an FTP server or any interesting additional dependencies that your tests had, you could and should, rather than using the Prophusion base image, define your own Docker image that is a layer on top of Prophusion base that includes those dependencies, and then you'd run that image instead. Okay. So that's just about everything. The only piece that we're missing at this point is what should the container run once it has, started up and mounted this volume and pulled in PHP 7.0.0. Of course, the thing that it should run is this phpunit test that I demonstrated above. And so we just give it the command that we want it to execute. Within the container, that would be /app, /vendor, /bin, /phpunit. And we'll have it run all of the tests in the tests folder again. Whew! All right, only 7 minutes and we have a command that should work. So here it goes. You see it right away found that it doesn't have PHP version 7 locally, and so it is going out and downloading it from prophusion.org. Okay, so it did that. Oops, okay. Looks like I have to give it the full path to the tests. Let's try that again. That looks better. All right, so it pulled in PHP 7. It ran phpunit, and we got the expected result. That was actually kind of convenient in a way, silver lining, that I made that mistake. You'll notice it downloaded PHP both times. Kind of a drag, right? Why would it need to do that? It already downloaded it up here. It seems kind of podunk that it would need to download it again. Well, it is. There's a better way, and I'll get into that just in a minute here with named volumes and Docker Compose. It's the same thing that's going to let us not have to type in all of this stuff every time. So don't worry, this can be improved upon. Just for fun though, I will show that at this point we have something where all we have to do to switch up the PHP version is change it right here, and I just picked something at random, 5.6.23. And so now it's going to download this different PHP version. You'll notice this one's 49.5 megs. The newer PHP 7, it looked like, is more like 61 megs. So yeah, it's a different version, but still our very simple application tests out just fine in that PHP version as well. All right, so let's say now that we want to do this a better way, a way where you don't have to type all of the commands, a way where you can share the settings with other developers by checking a file into your project and having them just run Docker Compose up. This sounds like a great idea. So in order to use Docker Compose, you'd make a file called Docker Compose.yml, and you just put that right within your project. Okay, so there's a little bit of boilerplate, because, there always is, right? it needs to know which version of the Docker Compose syntax you're using. Currently, pretty much anything you'd want to do would be Docker Compose version 2. Now, Docker Compose thinks of each Docker container as a service. It's essentially another name for the same thing. So we're going to have a section of our file called services, and everything that we put under here at this two tabbing level in nesting level is going to be a definition of another container. So we could put a separate one for different PHP versions, and that's eventually, once we build this out, exactly what we'll have. But let's just start with a single PHP version and a single container. You can call it whatever you want. I'm going to call it phpunit runner for PHP 7. Okay, and then it needs to know basically all of the things that we specified on this command line. So which image did we use? Well, we used Prophusion/Prophusion base. So we'll just tell it that. What else does it need to know? It needs to know which PHP version to run this thing here. Of course, the syntax is a little bit different. You can define your environment variables in an environment section, but the content is the same. This PHP version equals whatever string. Of course, I suppose this is supposed to be the runner for PHP 7, so let's change this back to 7. As of the time of this video, 7.0.12 is the most recent stable release, so I'll just plug that in. Let's see what else. So we specified on the command line this thing where I screwed it up initially. This is the code to run once everything else is all started up within your container. There's a little bit of an Easter egg in the Prophusion base image. If you're super familiar with Docker, Docker has this thing called an entry point, which is what is Docker going to run once the image is started. Prophusion base defines an entry point of its own. That's how it manages to pull in PHP right away as it starts up. But then if you define this environment variable called container cmd, then once it's done with its entry point, once the Prophusion base image is done with its entry point, it will run whatever you give it here. So let's define that and have it run our tests. Same command. Okay. We defined also this volume. That needs to be there. It's a little bit different again. So let's do volumes. And then on the command line, we had to specify the full path. Right now, on our Docker compose.yaml, this is going to be something that we're committing to Git ideally, and having developers run on their machines where their code could be checked out locally anywhere. So you wouldn't want to put this full path that's specific to my machine. Fortunately, Docker Compose lets you just put a dot to annotate that you mean the directory where your Docker compose.yaml lives. And then the rest of it is the same idea. We'll have that show up in /app within the container. So let's see what this all gets us. I think we've redefined everything that we had in this command line now within this YAML file. So theoretically, what that should allow us to do now is run docker compose up, and that's all we should have to tell it to get the same results. And there we go. So that wasn't so bad, really. So now let's see what else we can do, right? So only right now we're testing PHP version 7. What does it take to test a couple of them simultaneously? Well, let's define another service. And we'll put it, within the services section again. We'll call it something different. PHP 5.6. So 5.6.25. And everything else should stay the same. Let's run that Docker compose up again. Now we've got two of them. So you see here we have a download running for PHP 5.6 because it hasn't seen that one yet. That's fine. So now that finished downloading and ran, and the PHP unit runner for 7 was successful, and the PHP unit runner for 5.6 was successful. Can we do that again? Yay, okay, and this time it ran faster because we had already downloaded PHP 5.6, and you notice here it's saying attaching to these existing containers. So that's you know, a real easy way to not have to re-download PHP if you want to leave your containers sitting around on your machine. It has some downsides though, in that, you know, this particular test, like, it doesn't write to the file system. It doesn't manipulate the container really in any way every time you run your test. But supposing your tests were destructive to the environment that they ran within, so, you know, if you're doing a system test or integration level testing where it actually has side effects on the environment, you might also want to build into your testing process blowing away your container when you're done, so that you start with a known fresh environment every time. If you were to do that, you would also lose the PHP download every time, and you'd have to re-download it. So that's, I think, a common enough scenario that I want to, you know, just sort of show how you can bypass that. You can create something called a named volume. And what that'll do is when you delete the container, you'll lose everything but the stuff in the named volume, basically. And so if we create a named volume where the PHP versions are getting downloaded to, or, you know, that we mount where the PHP versions are getting downloaded to, then you can have the best of both worlds, where you can have a new, fresh test environment every time, except for the PHP binaries. So we can do that just by pretty straightforward. Let's first actually go down to the bottom of our docker compose.yaml, and at the root level we're going to define another element called volumes, and this just says, hey, this thing called PHP builds, let's call it that, is the name of a volume. Okay, so now that that's there, if we refer to PHP builds within our services, it knows that this means just create this name for a storage location, and let's mount that at the place where the PHP binaries are loaded within the container. So you kind of have to know where that is. It's in /user/local/phpenv/versions. This phpenv, by the way, is a really awesome project. That's one of the things that Prophusion is based on. Couldn't have Prophusion without it. You can, with phpenv, run multiple PHP versions just on your host machine if you want to, for example. Okay, so that's one little added tweak, and let's also copy this to the volumes section on our other container. Okay, so this should all still work just fine. Yep. Oh, actually, not quite. We got some warnings here. And it looks like it's unhappy that these containers are still kicking around. So I guess you only want to use the named volume definitions if you are in fact removing your containers. Let's just see if I'm right about that. So let's create a really quick bash script. Actually, let's call it run tests. That makes more sense. Run tests.sh. Okay, and this is just going to say, let's first remove our containers and then run docker compose up, right? Docker compose rm-f is going to remove all of the containers that are defined within this project's docker compose, and then docker compose up is the command we've been running all along. Indeed, I should add a shebang line. Better. Okay. Let's just make that executable. Okay, so the first time I run this now, we're going to do a docker compose rm-f. And that, I expect, is going to clear out these warnings, and it would also create a test environment that is a little bit more stable and consistent for every test that we want to run. And we would do that now by running just run tests.sh. Okay, so we have successfully run with no warnings, and you notice there were no PHP downloads either, and the tests ran in parallel. Oh, hang on, there was a PHP download? See if we get one again. Okay, that's better. So now it's downloaded all the PHP versions and it's working. So that's pretty much it. There's just a few other things that I'll show quick for demonstration purposes. This is how easy it is to do your tests within this environment. You don't have to like move code around or upload it to the containers or anything, since it is running right off of the host. Let's make one of our tests fail. So 1 plus 2 does not equal 2, so we would expect the tests now to tell us that something is wrong, right? And both versions failed. Very simple. One other thing that is very useful is this is a totally viable way to do continuous integration testing, for example, with Travis, which supports Docker. The one trick with that is, so what Travis usually looks at is, did your command that runs your tests exit with a code of 0? Well, let's see what our exit code is. Oops. Yeah, okay, so let's do this over. First of all, this was me screwing up. Then this was me checking the exit code, but it was the exit code of this command that was a screw up, not the exit code from my tests. So let me run the tests again really quick. Our tests are failing. What I'm trying to demonstrate here is that the exit code is unfortunately 0. And so if you just stuck your run tests.sh script as it currently exists in your Travis configuration, your tests would appear to succeed all the time. This is bad. So with a little bit of additional shell magic that I'm just going to copy paste into this run tests.sh, we can cause any failure in any of the containers that is defined in your docker compose.yaml to result in a non-zero exit code coming up at the end of the script. So that should be fairly boilerplate stuff that you don't need to change at all. And if we do that now, we should get a non-zero exit code if there are failures. Yep. And then let's just fix the test so that it does pass again, and run our tests and check the exit code. Now it's 0. Okay, so that's it. I will put this sample project complete with all of the docker compose.yaml and run tests.sh code up on GitHub, and link to that from the YouTube, so that you can find this code and use it as a starting point as well. Thanks for watching.